Class, I am going to explain you about Werner's theory from coordination compounds. After listening this theory, you can able to answer all types of objective questions in competitive examinations. Let us dive into Werner's theory. This theory was proposed by Alfred Werner. Hence, he is also known as father of coordination chemistry. Who is father of coordination chemistry? Alfred Werner. According to Werner's theory, a metal ion or a transition metal ion exhibits two types of valencies. One is primary valency, the other is secondary valency. What are the features of primary valency? We will discuss now. Primary valency is satisfied by anions only. Primary valency is satisfied by anions only. And secondary valency is satisfied by anions, neutral ligands, and rarely cations. And the next point in primary valency is represented by dotted line or dashed line, whereas secondary valency is represented by solid line or continuous straight line. Primary valency is ionizable. That means the ions which are showing primary valency are ionizable in their aqueous solution, but secondary valency is non-ionizable. When you dissolve it in water, the ions which are exhibiting secondary valency, they are not ionizable, and primary valency is equal to oxidation state of the metal, or primary valency represents oxidation state of the metal, whereas secondary valency represents coordination number. What is the meaning of coordination number? Number of ligands present in the compound or complex is called coordination number. Now, what example he took in order to explain his theory, we will discuss now. Alfred Werner explained the structures of the following compounds: COCl3 6NH3, 5NH3, 4NH3 and 3NH3 are there. So we will take first example, COCl3 6NH3. See, he wrote the formula of COCl3 6NH3 like CO NH3 6 and Cl3 outside the coordination sphere. There are two spheres in the complex compound. One is coordination sphere that can be represented within the square bracket. Outside the square bracket, the sphere is known as ionic sphere. It is what? Ionic sphere. The ions which are present in ionic sphere shows primary valency. They are ionizable. So this formula is also known as Werner's formula. In Werner's formula, cobalt is the central metal. Cobalt is the central metal ion or central metal, sometimes in complexes, central metal atom. It exhibits two types of valencies. One is primary valency, the other is one is secondary valency, the other is primary valency. And see, we will try to draw the structure of this complex now. Okay, the ligands which are within the side within coordination sphere are showing secondary valency. We will represent in solid line. The ions which are outside the coordination sphere are represented by dotted line. Dotted line. It is the structure of COCl3, CONH3 6 Cl3. Can you name it? It is known as hexaamine cobalt 3 chloride. Hexaamine cobalt 3 chloride. What objective questions are coming from this example? See, number of ions formed during hydrolysis. When you dissolve it in water, how many ions are produced? You know, the components which are present within the coordination sphere are non-ionizable. Complete this one is one ion. 3 Cl minus ions are other ions. So I am writing here CONH3 6 Cl3. When it ionizes, it forms coordination sphere is as cation plus 3, 3Cl minus. Total number of ions are 1 plus 3, 4 ions are formed. Here 4 ions are formed. Second question, how many number of moles of AgCl precipitate takes place whenever this complex is treating with silver nitrate, excess of silver nitrate? So, the ions which are outside the coordination sphere are ionizable. They will react with Ag plus from AgNO3. They form AgCl precipitates. So, how many number of Cl minus ions are there outside? 3. So, 3 moles of AgCl precipitate is formed. It is the second question. How many ions are produced? 4 ions. How many AgCl precipitates are formed? 3 moles of AgCl precipitate is formed. And how many ions are showing primary valency? 3. How many ligands are exhibiting secondary valency? 6. So this is the information regarding COCl3, 6NH3. Now we will take another example, COCl3, 5NH3. In this complex, how can we represent? Werner formula for this compound is CONH3 5, Cl is inside the square bracket and remaining Cl2 are outside the square bracket. Why? Because cobalt must shows 6 coordination number. Now, how we represent, what is the structure of this complex? See, 5 ammonias are showing secondary valency. They are represented in straight line, and 2 chlorines are there. They are showing primary valency, but 1 chlorine is inside the square bracket. It shows a dual valency. It shows both primary and secondary valency. It is also non-ionizable. See, whenever this complex is dissolved in water, how many ions are produced? 3 ions are produced. Complete complex is 1 ion plus 2 plus 2Cl minus 1 plus 2. 3 ions are formed when we dissolve it in water. And how many number of AgCl precipitates are formed? There are 2 chlorines are there which are showing primary valency, and these 2 Cl minus ions are reacting with AgNO3 to form 2 moles of AgCl. 2 moles of AgCl. Simply, what is the trick? How many ions, how many chloride ions outside the coordination sphere equals to the number of moles of silver chloride. And primary valency, how much is the primary valency? 2. What is the secondary valency? There are 5. And what is the dual valency? It is 1. 1 chloride ion is showing dual valency. So this is the information regarding COCl3, 5NH3. Now we will take another example, that is COCl3, 4NH3. See, COCl3, 4NH3. In order to satisfy 6 coordination number, another chlorine comes here, COs, NH34Cl2. What is the IUPAC nomenclature for this? Tetramine dichlorido cobalt 3 chloride. Cobalt 3 chloride. So we will discuss the nomenclature in the next class. Now see, 2 chloride ions are exhibiting dual valency. So in order to represent that one, so this is the structure of the above one. See, 4 ammonias are exhibiting what? Dual secondary valency. Here I am writing ammonia. Here I am writing chlorine. So one chlorine is outside the coordination sphere and it is showing primary valency. Now the questions. Number of ions are formed during hydrolysis are 2. When it dissolves in water, plus coordination sphere plus charge is there and Cl minus is there. 1 plus 1, 2 ions are formed. So 1 Cl is eliminated or ionized as chloride ion and it forms 1 mole of AgCl precipitate when it reacts with excess of silver nitrate, and it is the structure of this complex. And valencies information. How many ions are showing primary valency? 1. How many ammonias are there which are showing secondary valency? 4. And dual valency? 2. Many times dual valency is also considered as secondary valency because it is non-ionizable. And the last compound is COCl3 3NH3. So there are no chlorines outside the coordination sphere. Here 3NH3. The next example, last example. And what is the structure of this complex? See, I am writing the structure of this complex fairly. See, cobalt, XYZ axis. Ammonia, I am writing ammonia alternatively in order to represent secondary valency. And there is no primary valencies. Why? Because all chloride ions are inside the coordination sphere. Can you name it? Triamine, trichlorido, cobalt 3. So 3 chlorines are showing dual valency, like this, dual valency. Now there is no primary valency. 3 chloride ions are showing secondary valency. 3 ammonias are showing secondary valency, and 3 chlorines or chloride ions are showing dual valency. Since there are no chloride ions outside the coordination sphere, it does not react with silver nitrate. It does not form silver chloride precipitate. In these complexes, which cannot form AgCl precipitate, the fourth one is not forming the AgCl precipitate when it is reacting with excess of silver nitrate solution. How many ions are produced during hydrolysis? Only 1 ion. There are no ions outside the coordination sphere, hence it is not able to form number of ions. So the number of ions during hydrolysis is, when you dissolve it in water, only 1 ion. And very important question I want to ask you. 1, 2, 3, 4 are the numbers here. What is the order of molar conductivity? Order of molar conductivity of following complexes or compounds. Can you? So molar conductivity depends on number of ions present in aqueous solution. If number of ions increases, what happens? Molar conductivity also increases. In aqueous solution, it forms how many ions? 1 plus 3, 4 ions. 1 plus 2, 3 ions. During ionization of this complex, it forms 1 plus 1, 2 ions, as we discussed earlier. It forms only 1 ion. So number of ions decreases during hydrolysis, hence molar conductivity is also decreases. So what is the molar conductivity? Order of molar conductivity: 1 greater than, 2 greater than, 3 greater than 4. So it is the order of molar conductivity. Number of ions formed in an aqueous solution is also in the same order. And number of moles of AgCl precipitate formed in the aqueous solution is also same order. First one forms 3 moles of AgCl, second one forms 2 moles of AgCl, 1 mole of AgCl, 0 moles of AgCl are formed. So these are the objective questions which are frequently coming in objective examinations like JEE Main Advanced and NEET. So you are going to understand this concept. If you are unable to understand, please revise this concept again, and definitely I'm sure you will answer without any hesitation. Now I would like to ask you a question based on Werner's theory. Now understand this question. How do you solve this question? See, the secondary valency of cobalt 3 plus is 6. Calculate the number of moles of AgNO3. The number of moles of AgNO3 is added to 1.5 liters of 0.2 m COCl3 5NH3 solution. So here important keywords are secondary valency of cobalt 3 plus is 6. 6 ligands must be present in the complex. What is the complex he has given? That COCl3 5NH3. How can you write the Werner formula for this? CO NH3 5 times Cl out, and 2 Cl's are outside the coordination sphere. Now 5 plus 1, 6 coordination number is 6 in this complex. Now when it ionizes, it produces, when we dissolve it in water, it produces how many ions? Coordination sphere never be ionized, and plus 2 plus 2 Cl minus ions. 2 Cl minus ions are there. 1 mole complex produces 2 chloride ions. And how many moles of complex he has given in the problem? So from this data, volume is how much? 1.5 liter. Molarity 0.2. You know, molarity equals to number of moles by volume in liter. According to this, number of moles equals to 1.5 into 0.2. 1.5 into 0.2. So how much the answer is? 1.5 into 0.2. How much? Calculate. How much? 15 to 30. 2 digits left side. So 0.3 you get. Now 1 mole complex produces 2 Cl minus ions. Now 0.3 moles of complex produces how many chloride ions? So 0.3 into 2 upon 1 is equals to 0.6 moles of Cl minus ions are produced. It, when reacts with AgNO3, it forms 0.6 moles of AgCl. So 0.6 moles of chloride ion reacts with 0.6 moles of AgNO3 to form 0.6 moles of AgCl. So this is the answer. 0.6 moles is the answer for this question. Okay, thank you very much, and you may try to solve the previous year questions and whatever your questions which are practicing. Thank you.